Hello, I'm Dr. Nicholas Dogris, and today we're going to look at NeuroField ERP, or Event-Related Potential. This is an assessment test that was created to measure reaction times and attentional ability for both visual and auditory stimuli, utilizing a go, no-go ERP task. What does that mean? Well, basically, we put an EEG on a person, an EEG cap on a person, and we start a test. And let's say, for instance, in the visual test, you're going to see a go symbol and a no symbol. If you see two goes in a row, you click one time. If you see a go and a no, you don't do anything. Same for the sounds. If you hear two go sounds in a row, then you click. If you hear a go and a no, you ignore or inhibit. ERPs are tried and true. It's kind of like testing a reflex. When a person takes a test like this, we're dropping markers in the EEG. We can take this data after the test is done and conduct a specific type of analysis that can show us where the brain is creating a lot of latency or slowdowns in processing. And then that can guide our hand in terms of using neurofeedback or neuromodulation stimulation techniques for addressing those latencies. The test itself is fairly easy to take. You can see there's a test signal here, and I'm just going to run it briefly here. I put a P here and a P here just to kind of open it up. And I'm going to start the visual task. I can pop out the EEG window here so you can see that. That would be for the user. You can see the test signals running here. There's a go no, you ignore there. Go no, ignore that. Go no, ignore that. Go no, ignore that. And then we have two goes. I click. Again, I click. So you can see that there's a random time in between the two goes here. And you do a number of trials, and these trials are all going to be recorded in the data. And when you're done, the test will look like this. It'll tell you that it's done. You exit the task. And then you can see the responses. How fast is a person responding, and what's their average time. That's great. It stores that information. Later on, when they take the task again, you can actually conduct a study here and look at the differences between test 1 versus test 2 and so forth. And you can actually plot that data and then print it out or create a Word report for it. And then when we go back to the session dashboard, you can actually export the data in an XDF format. This allows you to take the data and put it in EEG lab for statistical and machine learning analysis of the data. And so you can epoch the data and create ERPs. ERP data is very compelling because when you actually start to do work with somebody, it's very specific. It can show you changes in the way that they're functioning. And let's see, let's choose somebody here and give you a brief look at what that looks like. So when a person can start a task, they start in initially. This is what a compiled EEG ERP looks like, and the 0 is the actual visual stimulus. And then you can see the potential responses when they first saw the object, and then how the brain responds here. Now what we see here is what's called a wide tail. This is a lot of latency or slowdown in the ERP processing. As treatment goes on, then what you start to see is a change in a person's ability to respond. So we go back over here and we'll just choose what they look like by the end of treatment. So here you can see now the response was quite rapid, and the amount of latency slowed down. And so when you actually look at the data from pre to post, you can see that that's what the person looked like when they started, And then after a series of sessions, then you can see how the ERP has changed and has tightened up, so to speak. And then this will match their behavior, hopefully, and what you start to see is improvements in different kinds of functionality, like reading or writing or attentional ability. So ERPs have a lot of utility, and we're really excited to utilize them because they make the use of neuromodulation much more specific and the measurement of treatment outcomes much more specific.